Yes. So see, after deciding the angle section, we have to we have decided the angle section. Okay, now we have to calculate how many number of bolts we have to connect. Okay, so design includes both the connection as well as a member, right? So already we have decided the angle section, and now we have to design the number of bolts. Okay, so in order to find out the number of bolts, find out the strength in shear. Okay, here single shear, why I have mentioned single shear means there will not be double shear here. Okay, because see, only one side only we will connect to the gusset plate and the angle. So ఏమవుతుంది, this will be the single lap joint. Okay, single cover single lap joint. Okay, కాబట్టి సింగిల్ షియర్ అన్నాను. స్ట్రెంత్ ఇన్ సింగిల్ షియర్ VDPB is equals to FUB by √3 into ANB plus NSASB into 1 by gamma MB. So FUB, you know that FUB is 400 divided by √3, and AN value is 0.78 pi by 4 d square. Okay, sorry, ANB value is 0.78 into pi by 4 d square. NN means number of bolts that are intercepting with the threads. Let us calculate this for one bolt only. Okay, so plus NS means, so single shear lo enti NS will not be existed, 0. So ASB will become 0 multiplied by 1 by gamma MB is 1.25. So that you can get VDPB is equals to 272 newtons. Okay, and next calculate the strength in bearing. Okay, so why we have to calculate strength in shear and strength in bearing? So which is among these three, which carries the less strength, that we will take, and based on that we will calculate the bolt value, means number of bolts we have to provide it, that based on that we will calculate. Okay, so for that strength in shear is calculated, and now strength in bearing. Strength in bearing is given by 2.5 into kb into dt into fu by gamma mb. Okay, so let us take E minimum as 1.5 times the diameter of the bolt. This is as per IS codal provisions only. E minimum, edge distance minimum will be provided as 1.5 into 1.5 times the diameter of the bolt, and minimum pitch will be provided as 2.5 times of the diameter of the bolt. Okay, so you got the 30 mm and 50 mm as edge distance and minimum pitch. Okay, so why we are calculating these means, we have to while calculating the strength in bearing, we have to calculate kb value. Kb value depend on edge distance and pitch distance. E by 3d naught comma p by 3d naught minus 0.25 comma fub by fi comma 1, which is the least of these we will consider as the kb value. So calculate the kb value. Okay, by assuming the minimum values of end distance and edge distance. Okay, so after that kb, okay, after that substitute all the values. 2.5 into kb is 0.4545 we got, multiplied by d is diameter of the bolt 20, t is thickness of the angle section, that is 10, multiplied by fu 400 divided by gamma mb 1.2. So I got 72720 newtons. Okay, so which is the least of which one provides the least strength? Strength in shear is least, means first the connection will fail in the shear. So we are considering bolt value as 45272 newtons, means a single bolt will carry a load of 45272 newtons. Single bolt in that connection will carry the load of 45272 newtons. Okay, so ఒక bolt ఇంత load calculate pair చేస్తుంది అంటే what is the upcoming load to the connection? 430 kilonewton. So number of bolts required is equals to upcoming load onto the connection divided by the load carried by the single bolt, so that you can get number of bolts to be provided. 9.5 we got, we will equalize it to 10 bolts. Okay, so you are taking 10 bolts and 9.5 volt తీసుకోలేం కాబట్టి we will take 10 bolts. Okay, and length of connection required, length of so here we are calculating for case A. What is case A? Connection without lug angle. First we have to calculate connection without lug angle. So for that we have to provide how many number of bolts? 10 bolts. 10 bolts is common whether it is connection without lug angle or with the lug angle. Number of bolts to be provided is same, but length of connection will be changed while providing for with the lug angle and without lug angle. Okay, so length of connection here required is equals to minimum pitch undali kada. Okay, pitch distance is 50 mm and means we have to provide 10 bolts with a minimum pitch of 50 mm. Okay, so what is the total length? 9 into 50, that is equals to 450 mm. Okay, 1 bolt end lo vachestundi kada, end distance ko vachestunది kabatti we will get 9 spaces in between the 10 bolts. So 9 spaces into okokka space means 50 mm. So 9 into 50 mm, 450 mm. So what is the maximum length of connection we will provide? 15D as per IS codal provisions. Length of connection, maximum length of connection is 15D, that is equals to 15 into diameter of the bolt 20, that is equals to 300 mm. Okay, so this but length required is 450 mm, which is greater than the maximum length. As per the IS codal provision we have to provide 300 mm length only, but length required is 450 mm, more ga undi. So it is a long connection, we are taking it as a long connection. So if it is a long connection, there will be shear reduction factor we have to consider. Okay, second bolted connections low, remember the bolted connection, there we have discussed about 3 reduction factors. One is for one is for long connection. Okay, and one is for packing plates. Okay, like that. So here it is a long connection, so we have to consider the reduction factor for shear, that is equals to 1.075 minus 0.05 into 450 by 20 fu by d. Okay, so you can get the reduction factor as 0.9625. So reduce the shear capacity. Shear carrying capacity is reducing due to the provision of long connection. Ante kada, ikkada without lug angle use chestunamante connection long ayindi. Long connection avvadam dwara shear carrying capacity is reducing. So we have to reduce the shear carrying capacity. So what is the actual shear carrying capacity? 45727 newtons. So but it has to reduce, it is reducing due to the long connection by 0.9 times. So reduce the shear carrying capacity 0.9625 multiplied by 45272, that is equals to 435743 newtons, means 435 kilonewtons only. Now please mute, all of you please mute. All of you please mute. Okay, so now this is the actual shear carrying capacity of the connection. So now what are the number of bolts required? So number of bolts is upcoming load by shear carrying capacity. So even the shear carrying capacity reduced, we have to provide 10 bolts only. Okay, now calculate the yield strength. Yield strength is, we have taken the AG as 1903, required is 1862 something, but what is the angle we have considered? 1903 multiplied by 250 divided by 1.1. Then what is the value? What is the yield strength we got? 432 kilonewtons. Okay, which is greater than 430 kilonewtons, which is the incoming load. So the connection is okay against the yield strength. Okay, same thing we have to sorry, we have to check in rupture strength and block shear strength. Okay, same as usual, as in the previous problem, how we check? We have to check the rupture strength and block shear strength because we have designed the connection. First, we have designed the connection, and based on that connection, whether that connection is safe against yield, rupture, block shear, that we have to check, right? So against yield strength, it is okay. So against rupture, we are now checking. TDN is equals to 0.9 ANC FU by gamma ML plus beta AG naught FI by gamma M naught. Okay. So ANC means net area of connected leg. Net area of connected leg. So 100 minus 10 by 2 minus 22 multiplied by 10. Net area of connected leg. Okay. Means connected leg lo, what is the net area? So what is the total width of the connected leg? 100 mm. We have to calculate the net area. So deduct the bolt holes. Okay, deduct the bolt holes from those and multiplied by 10 will give 730 mm square. Okay, and AG naught means gross area of the outstanding leg. What is the outstanding leg and connected leg? So if it is connected to the plate, it will be the connected leg, and this will be the outstanding leg. Okay. So while calculating the net area and gross area, up to center of this only we have to consider. Remember? Okay, do you remember that point? Up to the center of the leg only we have to consider. So 100 is the total, this one, right? 100 is the total width of the connected leg. This is the total width of the connected leg. Okay. And up to midpoint of the outstanding leg only we have to consider. What is the thickness? 10 mm is the thickness. So midpoint will be 10 by 2. So up to this length only we have to consider for the area. So 100 minus 10 by 2. Okay. Minus 22. 22 is the bolt hole, diameter of the bolt hole multiplied by thickness. That is equals to 730 mm square that we will get. And AG naught is the gross area of the outstanding leg. So this is the outstanding leg. Okay. So this is the outstanding leg. So up to the center only we have to consider while calculating the gross area also. So what will be this? The width, total width is 100 minus up to center, right? Up to center of the leg, connected leg. So thickness of the connected leg is 10 mm. So total length of the outstanding leg will be 100 minus 10 by 2 multiplied by thickness of the outstanding leg is 10. That is equals to 950 mm square. Okay. And again, another term we don't know is beta. So for that, beta is equals to, we have the formula 1.4 minus 0.076 multiplied by W by T multiplied by Fi by Fu Bs by Lc less than or equal to Fu gamma M naught by Fi gamma Ml greater than or equal to 0.7. So substitute all the values. W is the width of the outstanding leg. Okay. And T is the thickness of the plate. Fi, Fu, yield strength and the ultimate strength of the plates. Bs is equals to W plus Wi minus T, and Lc is the length of the connection. Okay, less than or, and this is the check for beta value. Okay, so substitute all the values. This already we did in tension members. Okay, this is not the new step. Okay, so after calculating, we will get the strength in rupture, and strength in rupture must be greater than the incoming load. What is the incoming load? 430 kilonewtons, and strength in rupture is 490 kilonewtons. So which is greater than 430 kilonewtons. So the connection is safe against the rupture of the critical section also. Okay, in the same way we have to check for the block shear strength